Hello everyone, hello and welcome to this Z Nights event. If the audio quality and the connection is good, then we can start the first presentation. Okay, let's start the first presentation. I am Balint Valai and this talk is presented to you by the Payment Tools team from Szeged, Hungary. Four of us would like to share our multi-year journey on how a little application grown to be a platform while splitting up into a modular architecture. First, let's go through the agenda. First, we would like to talk about what is PACMAN, what was our motivation behind the splitting, how we achieved this modularity. Then we will talk about the tool that we had to use. Then we would like to speak about our inner sourcing model, then present some lessons learned, then our tech stack and our future goals. Okay, so what exactly is PACMAN? This is a payments configuration management tool, an internal configuration tool with multiple modules to handle rules for different use cases. It has a collection of cost-cutting functionalities like publishing to S3 buckets, authorization and authentication, XLS support and auditing. The UI looks something like this. First, we have the business operators who are the users of this tool. They set up rules on the UI, then the rules are persisted in the database, and then later on it can be published to S3 buckets for our services that are integrating with this tool. So why split up the application? In the beginning, we had a simple service that was something like this, just a simple DB and a simple S3 bucket for our publishing. Then came other requirements, other modules that somewhat complicated the picture. So we quickly realized that we have the common microservice motivation, microservice splitting motivations, because these modules were decoupled and self-contained, and these could be deployed independently. So other teams started to develop modules into the ecosystem as well. Due to this, we had to start supporting the inner sourcing model. And this came pretty easily with the emergence of the tool, which we will talk about later on. So this all sounds pretty nice, but in reality, the splitting a live application where the main focus is to keep existing functionality alive, while we had to implement new functionalities both into the new and the old stack as well, while migrating different user groups and services between the old and new stack. And doing all this in 5 different environments simultaneously is very hard. So I will let Zoltan talk about the technical details of this split.
Okay, thank you, Balint. My name is Zoltan Mozula, and I would like to talk about our journey, how we split our architecture from the backend perspective. And it started with some design sessions where we identified our future steps. And after we started from bottom to top, that's why the first step is the database split. If you have seen the previous picture, our application had a huge database at first, and later we decided, because of the shame evolution handling, to split this huge database into smaller ones for each individual module. So we started this, and I collected some points here, what you should look out for if you'd like to do something similar, because it was a one Spring Boot application, which means that we had to add some multiple persistent contexts in one application, which was a bit tricky. And after that, because of this, each persistent context and the data source had their own connection pools. And because of this, we had some troubles with the database connection numbers. So we talk about this later. Csaba will talk about this later in the lessons learned section. And in connection with this, we had to modify the transaction handling annotation. We had to review all of our code and add some settings into this transaction handling. And because we use Flyway for schema evolution handling, we couldn't use the out-of-the-box solution. We had to initialize and configure this Flyway from configuration files, Java files. So it was a bit tricky. And the next step was to decoupling or source code, because all of our modules were in just simple Java packages. So we did some investigations and found that two approach can be a good way. Gradle submodules and the Java modules. We went with the Gradle submodules, and we started to extract these source code into Gradle submodule projects with their own build Gradle files. And I did also the lookout for section, because we had some troubles with, for example, the test coverage reports. We had our merge test coverage report for our entire application, and after we did this submodule thing, then the IntelliJ didn't support it too much, because it was an unconventional Gradle project. We had to do some tricky Gradle scripting, Groovy scripting, so it was a bit tricky. And beside of this, we had to review all of our library dependencies. I mean here that all of our modules had their own Java libraries, dependencies, third-party dependencies, and we had to add one by one these into these subprojects. And as I've mentioned, Csaba will tell you about more about the Java modules, why we decided that we will go with the Gradle submodules. The next step, while we did this Gradle submodule extraction, we identified that we had to have a core application, an additional Gradle subproject, where the whole entry point of the application can have their LDAP login and the GWT handling. We could add our monolith UI there, and we added some aggregating functionality for preparing for the distributed architecture. The shared library was the second sub-project what we identified and added. We added all of our common functionality like authentication, authorization, and we had different abstract classes, helper classes, and cross-cutting services like S3 bucket handling. So we added all of these into one shared library and one sub-project. The next step was Docker, around the Dockerizing. What we skipped, we had more time, and we could skip this step. But if we had less time, we would have done this, and I mean, we would have turned our Gradle subproject into independent Spring Boot applications and Docker images. and all of these could run on a standalone virtual machine. But at this point, we would have just one source code, one GitHub repository. So we went further, and the real split was here because we started to extract all of our source code into separate Git repositories. So we moved all of our sub-projects into real grader projects. So the real split was here. And beside of this, we added some proxy functionality for the core. And because the shared was an additional library, we had to add some release and versioning processes to add all of the modules as an external dependency. So that was a huge step. And after that, we could start the deployment. We did some deployment pipeline with the tool, what will be mentioned in the next slides. And because of this, we had the AWS account. Because of this, we had a bunch of access issues, APIs, and we had a lot of issues around S3 buckets. Csaba will tell you more in the lessons learned section. We added some VPC service functionality, and during this change, we migrate all of our secrets from Vault to AWS Secrets Manager, and we added some more observability support because of the new distributed architecture. And finally, you can see here that we have an independently deployable PACMAN Core application with the modules behind that. All of these modules are absolutely independent, and all of these, they have their own GitHub repository, their own release process, and with their own databases as well. And beside of this, we have the distributed logging, tracing, and alerting, and dashboards functionality. And at the top, we have some, as I've mentioned, the VPC functionality. So in the VPC, internal and external communication can happen through this from the third-party services. And from the backend side, that's all. Long story in short. And if you pay attention for the PACMAN Core or Web UI at this point in the PACMAN Core, but we went further, and here I would give the word to Viktor.
Okay, hello everyone. My name is Viktor Spesiak, and I'm going to talk about our UI architecture. So basically, we are coming from a modular monolith front-end application, which was an Angular single-page application. If you look at the diagram, it's part of the PACMAN Core, and every backend service has its own little piece of UI service in it. And if you think about it, that's going to be our bottleneck on the road of the separation, because every time if you change a service UI, you have to redeploy the PACMAN Core itself. It's not sustainable, and we are counting on a lot of service. So that's where the micro frontends came into the game. What is micro frontends? It's an architectural design approach inspired and named after microservices. In a nutshell, the idea is simple. You are having an orchestrator, a core application where you can plug in your little front-end applications, and they can work loosely together. The benefit of this model is you can develop simpler and smaller applications, and independent team can collaborate together. Now, let's move on the UI objectives. Our precondition is that we are working together with multifunctional full-stack teams, and they can come from different business areas with their own building processes and UI technologies. So our goal is to support any kind of UI technology stack, even the server-side rendering. The building processes is not really a problem because we only meet the end product of the services pipelines. Running whole application in one micro frontend. It's also an important point because we don't want to invent a new framework which is compose a UI application from little components. And we also wanted to support standalone development modes in order of fast prototyping. If you wish, you could bootstrap your application without our core and just start develop your own business logic. Now let's move on and see the first possible implementation. It's the custom elements or web components. In a nutshell, it's an abstraction where you can mount your front-end application into the HTML DOM. The first pro is it's having better loading and caching, of course, because you can loading the components individually. The communication between components is more convenient because you just pass some parameters to attributes or just call a JavaScript function. The cons are the routing problem if custom elements contains another router library. It's really tricky if you want to sync to a router library. Believe me, we tried it, our proof of concept application creation. No server-side rendering, of course, because it's a single page application technology. Build could be more complex, shared HTML, CSS, and JavaScript context, and unique lifecycle hooks. If you think about it, the Angular and the React application entry point is not the same, so you have to support all of them, even in different versions. It's a nightmare. The next one is the iframes. A little spoiler, we choose this approach. I believe I don't really have to introduce the iframe HTML tag because it's been there for a long time. But in a nutshell, you can embed the document into another document. It's having isolated context, it's technology agnostic. The frames can communicate through post-message API, which has been introduced in HTML5. The life cycles are the same because we just have to sit on the native iframe events. And it supports server-side rendering, of course, because it's having its own document. The cons are the increased memory footprint, loading time, and CPU. Of course, it's having much higher memory footprint and loading time because when you bootstrap your iframe, you have to download the resources independently, bootstrap your application, and so on. But as it has been mentioned, we are a configuration admin tool. Only operators will use our applications through the desktop environment, so we don't really care about this. Now let's have a look, how does it work? After a successful login, we issue you a JSON web token and redirect you to our dashboard, each tile hiding an external embedded module. If you register your application, you will have your own module and you can reach your application, the embedded application, through a tile. Now, if we click one of them, we will arrive to an embedded, you can say a micro frontend. The header and the footer is part of the core, and the inner data table is the child, is the embedded external UI application. We are providing URL state syncing and deep linking functionality. If you think about it, changing routing in the child module, you may you want to bookmark the link or just share with your friend, with your coworkers, and that's why we have to sync up the URLs into the core, and we link back. And the next one is error handling. For the simplicity, if you don't want to deal with the not found page, just messaging to the core, and we will handle this. We will redirect the user to the not found page, and of course, we issue forward our JSON web token for the security. Thank you. I'm giving back the word to Balint.
Okay, thanks. Now let's talk about the aforementioned tool that we shall not be named due to it being an internally developed platform that enables teams to migrate to cloud and build cloud native applications in our company. We can call it a cloud automation suite. So the integration with this suite was mandatory for our team, and it came at the perfect timing because it enabled us to integrate with it module by module, and we were able to onboard a single module first and test everything beforehand before we pulled the trigger for each and every of our modules. This tool consists of multiple services that are interconnected to help the developer by providing solutions for fast prototyping. From the start, the developer can use templates that initialize his or her project. This includes the creation of the GitHub repository, the skeleton application in it, and some basic configuration next to it. All he needs to do is just add the business logic. Next to the generated repository, there are some configuration and code as descriptions, infrastructure as code descriptor files that are consumed by the tools provisioning and deployment solutions. This enables the development team to only focus on the interesting part, the business features. So when they are adding the business feature, they just push their codes and the CI/CD pipeline is pre-configured and it gets deployed into the AWS stack that is provisioned by this tool. In different environments, there are monitoring tools in place already set up and configured with the templates to out-of-the-box support different type of alerting and dashboarding solutions. And in the background, there are tons of other microservices that are connected to in a big ecosystem to help the teams in cost tracking situations where the development team needs to be found for a deployed stack. From the get-go, we were aiming to create a template in this tool that our team can use for different modules, and other teams can as well use who want to integrate to the PACMAN platform. So now let's talk about all the benefits of this work. With this, each and every module can stay decoupled on both backend and frontend side. Teams only have to implement their business logic if the main conventions are followed, which is already given by our template in the tool, which is extremely speeds up the onboarding and development process. The template also provides the connection to the core application, which provides cross-cutting functionalities like authentication and authorization. This is also extended in our shared library that is pulled in by this template. For example, the auditing and publishing functionalities are in this library. And last but not least, as we mentioned before, the new module can be deployed with a fully integrated observability stack in place that is pre-configured by this template. So next up is the inner sourcing model, which is an approach where an internal proprietary solution is developed like an open source project inside the company. So this workflow looks like the following in our case. A new development team comes with their business requirements. They use the tool and our template to integrate with this platform. So they generate their code base, their Git repository, and their CI/CD pipeline. Then they add their business logic into the code base. They only have to test it locally with the integration and some Docker compose magic that is connecting together the PACMAN Core application, the shared libraries, and the module itself. After everything works, they push the code and deploy their application. Then they only have to create a single pull request where they set up the module itself for our PACMAN Core application, how they should connect. This is simply a URL where the module can be accessed. Then this whole module is pushed out into all of the environments, and then comes the profit. With this workflow, we follow conventions and do not enforce strict rules. This really speeds up the development, and the development team can fully own their own module, and no connection to us is really needed, only in the form of the integration PR. And we also created a 15-minute long video where we are generating a project from this template with this tool. And in 15 minutes, we push out our simple business logic into production, which is connected to the PACMAN Core application as well. And now let's hear some lessons learned from Csaba.
Thank you. I would like to talk about a few lessons that we learned during the development of this platform. Basically, we can call them lessons learned, but they are actually mistakes that we made, that we learned from, and we paid the price for it. So the first one, it's really interesting. We are using AWS S3 for our object store. S3 is a super simple solution, service, and strangely still there are very complicated attributes about it. The first thing that we learned is that if you have everything in one account, so the object creator, which is PACMAN in our case, and the object store, which is S3, and the object consumer, which is a service, everything is in one account, how do you solve your problem? You don't have to solve your problem because there is no problem. It's super simple. You can read the data, you can define it anywhere. You can define it on the service side, on a row level, or on the S3 bucket side. Everyone can read in the account your data. There are no questions about it. But there are more interesting setups which we went through and we learned. The first one is where the object creator and the object store is in one account, but the service, the consumer service, is in a different account. When you want to access the data stored in the bucket, you have to declare it on a bucket permission definition. Again, this is totally straightforward. There are no much lessons learned here. This is common knowledge. You are updating your bucket permission definition, and that's it. The service, you are allowing the service to consume the objects that are there. The thing is getting trickier when you have your service in one account, you're creating an object there, but you are storing the object in a different account, in a different S3 bucket, which is consumed there. Actually, we faced the situation when we were keeping alive the old and the new stack, and we had to support cross-publishing functionality. So what happens in this case? It's not enough to define on the bucket permission definition that whoever should be able to consume that object. You have to define for each object a canned ACL, and you have to set it as additional metadata where you are setting that bucket owner has full control. This way, whatever your S3 settings were earlier are actually taking into account, but without this, the service won't be able to consume the data that you were publishing. So we learned this the hard way. And if you paid a lot of attention for the previous 3 slides, you have a pretty good idea what is coming right now. Yep. So that's what happened when you have your service generating or creating an object in one account, you are storing the object in another account, and you have a consuming service which is in a third account. the previously listed ways how you enable access to that object will not work. There is on the AWS documentation on the really deep side, you can find a few words about it, and the solution is that you have to explicitly add a canonical user ID for each object, and that canonical user ID will describe which account should be able to consume that object. That canonical user ID is basically representing the account. It's like the account ID or the display name. These are just in examples. So before you have to hard code these canonical user IDs. Fortunately, we have a few accounts we are working with, so we were able to do this, and it's just a temporary measure, but still it was a pretty hard lesson to learn that it's not so easy to make your objects that are published available to be consumed. That was the first. The second lesson that we learned is around the abstractions. So abstractions, we learned at the university, really important. You are extracting the common logic, you are abstracting away what you think that needs to be reused later on. We understood that we will be creating modules, and those modules can be similar to each other, but we didn't want to make the mistake of abstracting everything and realizing later that okay, it makes no sense because everything is different. Actually, every module is like a snowflake. They are different in many ways, but from a really, really high level, if you are stepping far from the module, you would see that for our first module, we have the business logic in PACMAN, we have persistence in the database, we have some logic around exporting and importing data in Excel. We need to publish that data to an S3 bucket, and the consuming service is decoupled via the S3 bucket. Straightforward, no questions here. Still, we didn't do much abstractions at this point. Our second module arrived, and we were like, okay, I have seen this somewhere. It's pretty similar to the previous one. Still, we restrained ourselves, no abstractions. We duplicated what we could. What made sense to duplicate. We were waiting for our next module. Our third module arrived. There were no questions. Let's go ahead, abstract all the stuff that's related to S3 publishing, abstract everything that's related to Excel support and persistence. So we were really satisfied with ourselves at this point. So as you can imagine, our fourth module arrived, which was not even close to whatever we have seen so far. There were new elements, new models, we were consuming services, but we were thinking, okay, this is an exceptional case. We have seen our first three modules, we are going with that one. Of course, our fifth module arrived, which was again different from everything that we have seen so far. And the sixth module, okay, it's like the fifth one, but still we are seeing different patterns emerging. With our seventh module, please mind that the arrows are pointing now inside. That means that our small configuration management application is now behaving like a service because other services are consuming it. We had other different integration patterns, so all hell broke loose. With our 8th module, we were not even surprised that everything is different than expected. So what we learned here, what is the price that we paid? We had to re-implement 4 times anything that's related to Excel handling, because we were pretty confident that we know what they want, we know how they want to consume it, but every time it turned out that they need something totally different than in the previous case. On the UI side, we had a data table abstraction which became really bloated for all the special cases, and we are still struggling with it even after the split. We have a ticket which was created maybe years ago around handling the persistence via abstract rules and models, because it became, whatever we envisioned, totally useless. We had the fun to participate in postmortem, which looks like a long apology tour where we are introducing a lot of investigation results, and we are explaining why those production issues happened. And there is a different kind of review, is the correction of error, which was caused by a different kind of production issue, where we had to go in, correct, and again go to the root of the problem. For all of these cases, the problem was rooted in stuff where it turned out that we were abstracting where we shouldn't have to. That means abstracting is really important and useful, but in our context, in our use case, it looks like it wasn't the right way to go. So whatever we see, you see in our core or core application or shared library is a very thin logic, and we are encouraging the reuse of whatever logic we created earlier, but the abstractions were really painful for us. There was another interesting situation with database connections. So if you know, AWS is calculating the maximum number of allowed database connections by this neat formula. It's pretty simple. It came down to 90 for us, I think, for a small instance type. At that point, we had one big cluster, and all of our modules were connecting to that cluster. As Zoltán was talking about the database split, this is the situation where we have one application with many modules, but all of those modules has their own database connections. And everything was working just fine. On the database side, there is a default setting which is called wait timeout, which is set to 8 hours, which means that if a connection has no traffic for 8 hours, the DB will deem that connection down or dead. On the other side, on the application side, there is a flag called test on borrow, which will retest the connection when it tries to pick it up, and it's by default it's false. Actually, we set it to true, but we had so many database connection configurations. It turns out that when you are doing this manually, you have to be explicit. It doesn't inherit a lot of default settings that you are doing in your application. And in addition, at this point, all the operators that were using the applications were out for the weekend. So this is a perfect storm for us. All these settings are like what I explained right now. The operators went home, nobody is using the application. So what is happening? During the weekend, our modules one by one are crashing because everything is running out of DB connections because of inactivity. So it's like a Formula 1 car. You cannot go too slow with it. If you are going too slow, you are killing it. So it turns out if you are not using our application with these settings, it goes down. Again, production issue, we learned it the hard way. There were another lesson around code modularity. Zoltán already touched base on this, so we went with the Gradle submodule approach. But actually, we take a deeper look at the Java platform module system. We were really excited about it. You know, it's there since Java 9, lots of talk about it. Let's do it. We want to modularize our application. It's a great opportunity to go with it. But after taking a look at it, it turns out that still the tool and the library support is not that great for it. It's really cumbersome to fine-tune the transitive dependency, and there were issues with Spring compatibility too. As we were thinking about this, whatever we are doing here in the Java module specific side will be a throwaway code as we are going to the next step when the code is actually separated and goes into its dedicated repository. So it looked too much work for something that won't stay with the application, so we decided to go with the Gradle submodules. It's a more lightweight solution, still gives you whatever separation you wanted to do, but as Zoltán mentioned, again, some tool supporting is not that great around it. Our lesson was that if you can, you should go with the simpler solution, not the hyped one. Another thing that could be interesting is around dependency locking. The conclusion on our side was that just do it only when you are really committed to do it. And you have to use it in the right way. what I mean by the right way, it turned out that we used it in a way where we logged a bunch of dependencies, but there were also a lot of dependencies which were not logged, which resulted in constant regeneration of the log file, which updated for all the versions for all those dependencies that were not logged. And as you can see, it was not, you were never sure what happened here. So did I run the generate or did I not run? Was my dependency update picked up or not? This was working yesterday, I rerun the stuff and it's breaking today, and I'm always conflicting with someone because of this. So it was a lot of struggle for us. We even built a dedicated infrastructure where a Jenkins job picked up our repository, built the latest version, updated the dependencies. If the build was successful, it opened a pull request to our repository. But it was so much work and we didn't see the benefits of it. Again, if your situation or context requires this, please go ahead. But for us, it was too much trouble, so we moved away from it. And another thing that we faced quite a lot when we moved from a shared library to another, it turned out that there were a bunch of bean definitions in those libraries which we were not even aware of. So when our application started, picked up all of those beans, and there were some underlying logic that was happening and we didn't even know about it. So that was scary to realize that there were things that are happening and we are not controlling it and don't even know about it. So after further discussion and experience, when we created our new shared library, we decided that the shared code and logic can be in the library, but you have to and should be explicit on your application side. Whatever you want to pull, whatever you want to use, just be explicit, create a bean for it on your side, on your configuration side, and that's it. It caused a lot of problem again for us and around, I think, SSL certificates and health checks mostly. So we talked a lot. What you have seen, our platform is using these technologies. So on the front end, Angular is driving everything, so Angular and related technologies. And on the back end, it's Java and Spring Boot. Maybe it's worth mentioning Flyway that we are using for schema migration. And we are using Hibernate Enverse, which we haven't even heard about before we started all of this, which is responsible for the history and audit functionality out of the box. Everything is in AWS, and I think Zoltan or Victor mentioned the GWT token. That's what we are using for authentication and authorization purposes. Everything else is pretty standard, I think. We have, of course, plans for the future. We are planning to extend the platform with a parameter manager. It's like a configuration tool for the operations person, so whatever they can set up there should be reflected in their specific tools dropdowns. It doesn't sound like a big thing, but they are waiting for it like the Holy Grail. And no, it's not like Spring Cloud configuration. That's for the application, not the business. What we also are trying to build is the automatic module registration. You remember that Balint was talking about the inner sourcing model where the guys have to open a pull request with the URL of their application. So of course, we haven't spent too much time with it, but it's possible to update that and make it automatic. So whenever a module comes up, should be able to register itself automatically, tell that this is my backend, this is my UI, please generate my tile and take care of my authentication and authorization stuff on the core side. And we have LDAP integration right now, but we already have the design for the Okta SSO integration. These are our main plans. We have a timeline here just to show you guys that this was quite a big undertaking. As it was mentioned earlier, we had to support the existing functionality, we had to extend the existing functionality, we had to support both the old and the new world. A lot of users were migrating, a bunch of them not. A lot of services were migrating, a bunch of them not. So everything had to be synchronized. So we started at the end of 2018 with the database split, and we are in Q2, and we are working on the central parameter store, and there are already at least 2 new modules in the pipeline which are not created by us, but as picked up as the inner sourcing model that we touched based upon earlier. A few notable numbers. We are supporting 5 environments. We have 10 applications running right now. We own 45 buckets. We have 50 databases and 82 instances. So again, this is not some high load, high volume operation. We are solving different kind of problems, but still interesting. Okay, so I think this is the point where we can check the questions.
Yeah, there is one question in the YouTube comment section. So it's the question is about is PACMAN open source? So the answer is we have to go back to the inner sourcing model. So we are behind non-disclosure agreements, and we are working for our clients. So unfortunately, PACMAN is not open source, but it is in an inner sourcing model. So it is open source inside our company.
Okay, so if there are no other questions, then thank you for your time, and hope you enjoy the agenda further.